Hello students, welcome to SB Maths class. After long days we are meeting at the video class here, and I hope you have enjoyed your puja vacation properly with proper enjoyment, but also not away from your studies, because you are in class 11, so obviously you are very much serious about your studies, I know. So I think you have studied well also with the enjoyment of the puja. So today we will start the new chapter, and also one of the very interesting and also very important chapter for the higher studies, that is the complex numbers. Up to class 10 you have dealt with the real number system, the totally real numbers are there, and now we are just doing a paradigm shift of the from the real numbers to the complex numbers. Actually the old students of our school, you know, that is I have given you some of the hints when we are doing the quadratic equation at class 10, that is whenever the discriminant, the value of the discriminant will be less than 0, then the roots of the quadratic equation will be imaginary. So what is the imaginary? There also have written one imaginary. What is the imaginary number? That is I equals to root over minus 1. So for the new students, I am again discussing that one. That is the numbers under the root but also with the negative sign are called the imaginary numbers. So like that, I can write like that, that is if x square equals to minus y, where x and y both are, here I am taking the integers, z plus positive integers I am taking. So if this condition is that x square equals to y, that is square of one number is negative. In the real number system it is not possible, but here square of one number, if it is coming negative, then that number x is called an imaginary number. X is called an imaginary number. As for example, x equals to root over minus 1, root over minus 2, root over minus 3, and so on. So this is the fundamental concept of the imaginary number, that is whenever the square of the number will come negative, then the particular that number will be called the imaginary number. Okay, so imaginary numbers, actually if this is root over minus 2, it can be written as root 2 into root over minus 1. That means if this we want to write, then it is coming root 3 into root over minus 1. That means any imaginary numbers can be represented as the multiplication of root over minus 1 into some other things. So here root over minus 1 is the base of the imaginary numbers. It can be written as I. Actually this is the like this. This is one not like that, like this. Not actually it is not the opposite integration. Looking like that. So it is called the iota, the Greek letter iota. So with the help of iota we can write the root over minus 1. Just we take the value of iota is equals to root over minus 1. Actually it is transliterated to now the English letter small I. So I equals to root over minus 1. So if I equals to root over minus 1, I square equals to minus 1 here, I cube equals to minus of root over minus 1, so minus of I, and I to the power 4 equals to 1. Okay. So you have to keep in mind those values. Only if you want to keep in mind I equals to root over minus 1, that is also okay. You can find the other things. Now, with respect to this discussion, some very easy examples are there. Often it comes at your exams for 1 mark or 2 mark questions. So let us do this one. So find the value of example 1. Find the value of, or find I to the power say 94. Yes, I to the power 94. So students, here one thing you have to keep in mind, that is I to the power 4 is equals to 1. So whenever this type of sum will come, so try to express that power, this 94, at the power of 4. That is, I want to say, that is, if you want to express this one with respect to the power of 4, then I to the power 4 equals to 1, that will help you. So here 94, if you do the here the factorization, so it is coming directly, it is coming of 9. Okay, so okay, then so 94, so 4, if you do that divide it is, so 4 2 or 8 1 4 2. So that means 94 can be written as 94 equals to 4 into 23 plus 2. So that just like that, I to the power 4 into 23 plus 2. So that means I to the power 4 to the power 23 into I square. Okay. So I to the power, that means it is 1 into minus 1. So definitely it will come minus 1. Okay, and some of another examples are there, that is, if we write like that, example 2, prove that I to the power n plus I to the power n plus 1 plus I to the power n plus 2 plus I to the power n plus 3 is equals to 0. So you have to prove this one. So for this one, if we want to take like that, if we take I to the power n as common, so 1 plus I square plus I cube. So I to the power n is there, 1 plus I square equals to minus 1 and I cube equals to minus I. So definitely it is coming 0. So very easy examples are there, no any proper problematic sums are coming from this part of the chapter. So students, I think you can deal with all of these examples, isn't it? Okay. Okay. So you will do the exercise problems here. I am not doing those. We'll go to the next part, that is the main part of the chapter. So this video is up to this. We will discuss about the proper complex number at the next videos. So thank you students.